Hello and welcome to the channel. Today we'll be looking at a website called PLC IOSim, a ladder logic simulator, which has provided us with 24 different challenges that we're going to try and work our way through in a small series of videos here. We're going to jump right into it, but first of all, just smash like and subscribe as always. Challenge 1, here we go. For project 1, they want us to design a program to control a lamp using a normally open push button. You can press the push button to turn on the lamp and release the push button to turn off the lamp. So all we have to do to make this happen is add one contact, which will represent our push button, and add one coil, which will energize our lamp. And this way, when we go into run mode and press the push button down, our push button contact will close and energize our lamp coil, which will in turn energize the lamp. And when we release the push button, this contact will open, the coil will de-energize, and the lamp will be off. So that's one down, 23 to go. Alright, let's see if we can do number 2. Design a program to start and stop a conveyor. Pressing the normally open start button should start the conveyor, which will continue to run after the push button is released. Pressing the normally closed push button will stop the conveyor. So first we're going to put our stop button. This is going to be feeding a parallel branch here, which will all be feeding the motor. That's not what I meant to do. That's better. So we'll make this first one into the stop contact. And you'll see how the stop button is normally closed. This is actually a common practice, and there's a good reason for that. Imagine we were trying to run this motor and we had a fault in the stop circuit where the wire became disconnected or broken in two. Then that way, because you lose this constant signal, it changes from a 1 to a 0, and the motor will just turn off and you won't be able to turn it on. So if this stop button was instead normally open, like the start button, what would happen if you had the same fault where you had an open circuit down the line here? You would click the stop button and nothing would actually happen because you have an open circuit and the signal can't go through. And that way you wouldn't be able to stop the motor in the case of a fault, so that wouldn't be good. So that's why we use normally closed stop buttons. Anyways, since the button is normally closed, this contact will be normally closed, and we have power feeding this parallel branch here. To turn on the motor, we could just use the start button, and then this circuit will behave the same as the first circuit that we made, where when we click start, the motor will turn on, and when we release start, the motor will turn off. That's what this contact is for. It's known as the holding contact, and this contact will close as long as the motor is running, and we'll see what that does. So we click start and the motor turns on. That's also going to close this holding contact because it does the same thing as the motor does. So when we release start, we still have an alternate branch for power flow, so the circuit won't actually turn off. It will only turn off if we click stop. And that's number 2. Let's see if we can get number 3. Water tank. Okay, this one looks a bit different. Design a program to fill and drain a water tank. Pressing the normally open push button number 1 will fill the tank until the water reaches the normally open limit switch for full. Releasing the push button number 1 will stop the filling operation. Pressing normally open push button number 2 will drain the tank until the water reaches the normally open limit switch low. Releasing the push button number 2 will stop the drain operation. Cool. So I think for this one, we'll need 2 rungs, one for fill and one for drain. So we'll have a fill button. Oh, not a fill button. This will be push button number 1. That will be push button number 2. They're each going to be controlling an operation. Push button number 1 will control the fill operation. And push button number 2 will control the drain operation. So let's just run this. We can see that it works. However, the problem is if we just let it keep running, the tank is going to overflow. Unless you have somebody supervising these buttons at all times. So that's the purpose of these normally open limit switches. So the full switch will go in this branch, and it will be a contact as well. Now this will be a normally closed contact for fill. The switch in real life is normally open. However, this contact in the logic needs to be normally closed, because when the switch is open in real life, the water is not filled and has to keep filling. In order to keep filling, it has to be able to pass through this contact. So, now we'll watch what happens when we keep filling the tank. Oh, I think it's glitching because it was already full. So I'm going to drain it and do it again. No, it's just glitching anyways. Oh, that's because I used the this should be high, not fill. So this is the high switch. I'll drain it a bit and see if it works. Boom. You can see when the water fills up to a certain level, the normally open high switch will become closed, and this contact here will become energized and open up, making it so you can't fill the tank. Now we need to do the same thing for when we're draining it, otherwise it will just keep draining unnecessarily. So how are we supposed to do that? This will be the same, but we'll just use I think we'll just use a normally open contact for this one. For low. Because as long as the water is above that switch, which it basically always will be, that switch will be closed, allowing this to be closed and drain the output. See it automatically stopped? There you go. Now that's how you can automatically fill and empty a bucket, ladies and gentlemen. Alright, let's go on to number 4. Alright, number 4, garage door. Now this one basically turned out to be the exact same as the last one, but instead of a water bucket, it's a garage door. And you're controlling the forward and reverse motor contacts. This one just only ended up being different because both of the switches are normally closed now in the logic, instead of just one of them. So I didn't think it would be that interesting to go over all of that again. But you can see, you click open and it will open until it gets all the way open. And if you click close, it will close until it gets all the way closed. And yeah, not much to that one. So we'll just move on to number 5. Alright, number 5. Push button stop light. Design a program to manually turn on and off the 3 lamps of a stoplight. Push button 1 turns on green. Push button 2 turns on yellow. And I think that's a typo. Push button 3 turns on red. So this should be easy peasy. So push button 1 will turn on green. Yeah, so this is the exact same as the first one that we did, but there's just 3 of them. Let's check it out anyways. Alright, push button 1 does green. Push button 2 does yellow. And look at that, 3's doing red. Alright, that's going to do it for challenge number 5. Let's see if challenge number 6 can step things up a bit. Design a program to manually turn on and off the 3 lamps of a stoplight with interlocking. Okay, so they've added interlocking. So it's the same except for no 2 lamps can be energized at the same time. Interesting. Yeah, so I'll just make what I made the last time quickly. I'll show you what they mean about this. We'll just go green, yellow, red. Green, yellow, red. However, this if you program your traffic light like this, it might be deadly. Because then you have green and red at the same time. And so, yeah, that's probably not good. So we're going to add some interlocking. So how do you add interlocking? Well, let's say I want to turn on the green light. Now if the green light's on, I want the other 2 to be off. So basically all you have to do is add a normally closed contact, which represents the green light. Now what does that mean? That will be in series with the other 2. That means when you turn on the green light turns on and both of these normally closed contacts will become open because they will be the opposite of what the light is. What that means is if you click your other push buttons, ain't nothing gonna happen. It's as easy as that. So I'm gonna add ones for yellow on the other 2. I'm going to add ones for red on the other 2 that aren't red. There you go. And let's just see if that works. So green is on. Can't turn on the other ones. Yellow is on. Can't turn on the other ones. And red is on. Can't turn on the other ones. Sweet. Now that's all the time we have for this video, but smash like and subscribe so we can complete numbers 7 through 24.